Welcome to Lecture Online. In this video we're going to talk about the line of symmetry. Now here we have 5 different shapes. Here we have a triangle. Well, there's 2 different types of triangles. There's an isosceles triangle, there's an equilateral triangle, we have a parallelogram, we have a square, and we have a pentagon. Now, can we draw lines in such a way that the line will divide the object that we have, the shape that we have, in 2 exactly equal parts? It turns out we can. Over here, if we draw a line from the vertex up here to the halfway point on the base right here, straight down, then you can see that the left triangle is exactly equal to the right triangle, and therefore that is what we call a line of symmetry. With the parallelogram we can do the same thing. We can go to the halfway point of the top here and the halfway point of the base, and if we draw a line from that point to, let me try that again, draw a line from one point to the other right there, you can see that the 2 halves are exactly equal in shape and size. We can also draw a line from the halfway point over here to the halfway point over there, draw a line this way, and again that line divides the shape in exactly 2 equal parts like that. How about a pentagon? Can we do it with a pentagon? The answer is yes, because all the sides are equal in length, so they're all congruent, and all the angles are equal to one another. So therefore, if we draw a line from the vertex to the base on the other side, like this, you can see that you can divide this pentagon in 2 exactly equal shaped halves. We can also draw a line from this vertex to this base over here, or that side over there I should say, and again it divides the pentagon in 2 exactly same shapes halves. We could draw a line from this vertex to that side over there, and again divides into exact 2 shapes. We could do it again from here to there, and finally from there to there. And notice there are 5 different lines of symmetry that we can draw in the pentagon, each one of them dividing the pentagon in 2 exactly equal sized halves. With an equilateral triangle, just like since with a pentagon we can draw 5 symmetry lines, here we can probably draw 3 symmetry lines, and the answer is yes, we can. From the vertex down to the base, from this vertex to the side over here, and from this vertex to the side over there. Notice in each case it will cause the triangle to be divided into 2 exactly same shape and size triangles. Of course, same shape meaning it's kind of the mirror image of the other, because you have to flip it over to have the same shape. Now what about a square? It has 4 equal sides and 4 corners. So how many lines do you think we can draw, lines of symmetry? Well, it turns out we can draw a line straight across this way. We can draw a line straight across this way. We can also draw a line straight across this way. And we can draw a line straight across this way. In each case, we divided the square in 2 exactly equal size shapes. Now what about the parallelogram? Do you think we can do the same as we did for the square here? And I believe the answer is yes, because if we draw a line from corner to corner for opposite corners, again, that's a line of symmetry. It divides the parallelogram in 2 exactly same size or same shape halves. And if we draw a line this way, again we can do the same. So notice there again there are 4 lines of symmetry in the parallelogram as well. And that's what we mean by the concept of line of symmetry.